I hand you a trial lens right now, without looking at the label, can you tell me in 5 seconds whether it is spherical or cylindrical? Today, I am going to show you the 4 reliable methods to identify spherical versus cylindrical. The cross-line distortion method, the movement method, the tactile method, and the image size method. Before we get into the details, let's quickly understand why this matters. A spherical lens has an equal curvature in all meridians. It focuses light into a single point. A cylindrical lens has a curvature in only one meridian and its another meridian is flat. And it focuses light into a line, not a point. This difference is the entire basis of correcting astigmatism. If you cannot identify which lens is which while sorting your trial set, you cannot build an accurate prescription. This is also a very common practical question where your examiner hands you an unlabeled lens and asks you to identify it on the spot. So let's go through all the 4 methods with a real demonstration. The first method, cross-line or distortion method. This is the fastest and most commonly used method in clinical practice. You need a simple target like a plus sign or a cross drawn on a piece of paper, or you can just use the tile connection on the floor as a cross line. I am using this one right here. The target should be steady and bring the lens above the cross and observe the cross through the lens while rotating your lens into 360 degrees. Let's start with the spherical lens. As I rotate the spherical lens, notice the cross lines stay exactly the same and there is no distortion throughout the rotation. There is no tilting, no break, no bend, no matter what angle I hold it at. This is because spherical lens has the same curvature in every meridian. So light bends equally no matter which direction you rotate it. Now let's look through a cylindrical lens at the same target. Watch carefully now as I rotate. At certain angle, one of the lines appears to tilt or break or separate from the other, and it's creating a distortion. This happens specifically along the axis of the cylinder. This happens because a cylindrical lens has a power in one meridian and another meridian has no power. So one direction focuses light and the other does not. That mismatch is what creating this visible distortion as you rotate. The second method, the movement method or the motion method. This one is extremely useful and it is actually the same principle used in retinoscopy. For this, you need a stable target. I am using this one right here and move the lens side to side while observing how the image moves. You are going to observe the movement of the image and identify it. That is why it's called movement or motion method. Here you need to know about with and against movement. In with movement, image moves in the same direction as lens. In against movement, image moves in the opposite direction to the lens movement. Let's start with a plus spherical lens. See that as I move right, the image moves left. If I go left, image moving to the right. This is against movement. This is the classic sign of plus spherical lenses. Now with a minus spherical lens, if I move to the right, the image is also moving to the right in the same direction. This is called with the movement. This is a sign of minus spherical lenses. Now here is the key difference with cylindrical lens. With a spherical lens, the movement is same in every direction you move it. Horizontal, vertical, diagonal, it doesn't matter. The movement begins identically. With a cylindrical lens, this is different. Let me show you that. Now I move the cylindrical lens horizontally. Watch the image. Along this meridian, you see clear movement either against or with. Here it is with because it's a minus cylindrical lens. Now I move it vertically along the other meridian and notice there is barely any movement at all. The image is staying almost still or moves very minimally because this meridian has no real power. This asymmetry, strong motion in one direction and minimal in the perpendicular direction is the classic sign of cylindrical lens. This is also exactly the principle behind retinoscopy when you are mapping out an astigmatic eye. Method 3, tactile method. This one is simple but very useful, especially for high power lenses. Here we are just going to feel the lens with our fingers. For a plus spherical lens, notice the center is thicker and it's thinner in the edges all the way around uniformly, no matter which direction you trace your finger. Now with the minus spherical lens, feel the center, it's thinner and the edges are noticeably thicker. Again, it is consistent all the way around the lens in every direction. Now here is the important clinical point. For cylindrical lenses, the tactile method is not reliable. This is because cylindrical lenses typically have one flat surface and one curved surface. So the thickness change is only happening along one meridian, and at low powers this difference can be very minimal to feel by hand. So use the tactile method primarily to confirm whether something is spherical lens, especially at high powers where the thickness difference is obvious. If lens feels uniform in thickness change from every direction, it's a spherical lens. If you are unsure or the lens is cylindrical, always go back to the crossline test or a movement method. Those are far more reliable for cylindrical confirmation. Method 4, the image size method. In this method, we are going to identify using the size of the image through the lens. For plus spherical lens, notice the letters appear larger, magnified compared to looking at them without the lens. This magnification is equal in every direction. The letter is bigger in both height and width. Now through a minus spherical lens, the letters appear smaller and minified. Again, this minification is equal in every direction, and the height and the width both reduce in the same level. Now watch what happens with a cylindrical lens. Looking through the cylindrical lens at the same letters, notice the letters is not uniformly magnified or minified. Instead, it looks distorted in one direction only. The letters might appear wider but not taller, or taller but not wider, depending on which meridian carries the power. If I rotate the lens 90 degrees, watch the distortion flips to the other direction. This uneven and direction dependent distortion is the clearest visual giveaway that you are looking through a cylindrical lens rather than a spherical lens. So in a real clinical or exam setting, use the crossline test or the movement method as your primary tools, since they are the most reliable and fastest method. Use the tactile and image size as a secondary confirmation, especially the tactile method only for high power lenses. If this video is helpful, like, share and subscribe to iCareOptom. I'll see you in the next video. Click, clap, pull it. Click, click, pull it. Go.